verify not that your answer is correct, but that your work is correct. I told you when I taught this that I expect work for all the other 4 trig functions in memorization or looking up is only okay for arcsine and arctangent. So I should see you rearranging this. Cosine y equals 3x, like that. Yeah? I should see an implicit derivative. What is the derivative of the left side? Negative sine y dy dx equals the derivative of the right side. 3. I should see you isolating dy dx. dy dx is 3 over negative sine y. I should see you replacing sine y with something x-ish. How do I replace sine y? I should see a triangle. Okay? According to this statement here, cosine of an angle y is an angle, you take the cosine of angles, gives you an adjacent to hypotenuse side ratio of 3x adjacent 3x over hypotenuse 1. That's super, but to get the sine, I need opposite to hypotenuse. So how do I find the opposite side? Pythagorean theorem, I get the square root of 1 minus 9x squared. With that, then, I can replace sine y with opposite to hypotenuse, which is the square root of 1 minus 9x squared. There's a negative in there, sorry. Are you with me? That's the work I should see. Okay, this one. Look at your work. If you don't have 1, 2, 3, 4, 5, 6, 7, 8 steps, you might as well put -1 in that box right now, because I surely will. It can take us some time. Okay? I expected, and I clearly communicated what I expect to see. I clearly expect you to see that velocity is the antiderivative of gravity. One of those 2 statements or both needs to be met. If I don't have an integral in your box, obviously you're not doing it the way I asked. All right? So the velocity is negative 9.8 t plus a constant. I should then, there's a curve. I shouldn't see the next step. Identify the constant. It is show how the initial is used to find the constant. So if you have c1 equals blah, that's not what I want. I want that the velocity is negative 20 when the time is 0. The whole initial condition being used. Do not always assume that I will give you time 0's condition. Get in the habit of plugging in the whole thing, time and velocity. And then last but not least, identify the answer. Velocity is negative 9.8 t minus 20. That's the 4 things I expect. The antiderivative, the integral, the antiderivative, the initial being used, and the answer. Do the same thing for height. Height is the antiderivative of velocity, so the antiderivative of negative 9.8 t minus 20 with respect to time. Show the antiderivative, negative 4.9 t squared minus 20 t plus c2, or new constant. Show the initial being used. At time 0, the height was 160. So 160 equals 0 minus 0 plus c2. That means that the height is negative 4.9 t squared minus 20t plus 160. Do you have 1, 2, 3, 4, 5, 6, 7, 8 steps shown? Excellent. Then, finding when it hits the ground. The ground implies that height is 0. Now, as we know, quadratics have 2 solutions, but you'll find that this is going to get a negative and a positive. Negative would be like if you went backwards in time through his arm and traced the ball back to where it would hit the ground. That's not the one we want. We want when he's throwing it down, when does it hit? And that's the positive time version. So choose the positive time version. I got 1 point something around there. 1.470-ish. Do you agree?
I got 4.
I got that.
You got 4.027?
I got 4.027.
That's okay. What did I do wrong? Did you use a program or did you use it by idea? Did anybody get what I got? Flannery, Stenzel, you people back there, what about you guys?
I got
4.027? What did I do wrong? Well, that's not your problem, is it? I'm kind of curious. All right, 4.027. .027. What was your initial velocity? Do you have a negative 22 here?
Yeah.
Huh. Okay. I guess your answer makes more sense than mine. 1 second. That's pretty quick. You're right. Okay. I'll have to figure out what I did wrong. I don't know. Maybe I have an error in my programming. Okay. So, last but not least, segueing into the lesson for today. Look at your quiz. If you missed number 1 because you gave a negative area, then you best go back to basics and learn from your mistakes and pay very close attention to this lesson. Let me say this clearly. If the problem is just evaluate this integral, is negative okay? Can this be negative? Yes, negative is okay because integrals can mean lots of things, negative movement or something. So sometimes I want negative, and that's okay. But if the question says, find the area, should the answer be negative? No, it should be positive only. And if I were taking a multiple choice test and the question said, find the area, the first thing I do is look for every negative and scratch it. Gone. Not even a choice. Okay? Positive only. So if you ever get a negative area, then you did something wrong. Now then, the next question is, what do you do if you get a negative area? Do you just erase it and pretend the answer was positive? No. Do you just slap some absolute value on it? No. You will actually set up a positive area. Now, I beg you, I understand some of you are saying, I just take the absolute value and it works every time. Well, it does work every time for area, but it doesn't work every time for volume. And I'm trying to prepare you for volume. So will you please set it up the proper way, which is to say, set up a positive base and a positive height. That will never fail you. It will not be some little gimmick to cancel out the mistake you made in the setup, like absolute value is. Set up a positive base, a positive height, you'll get a positive area. That would mean then that if you have a region like this, and you have rectangles, that when you sum the base and the height, that the bases are all little changes horizontally, which we call dx. And the heights can be made positive by taking upper minus lower. Now that might mean curve minus curve, f of x minus g of x. It might be 0 minus the curve if it's below the axis or something. Upper minus lower makes all positive. And you go left to right on the bounds, which makes dx positive. Okay? Now today, you're going to do a little different. Today, you're going to look at an integral more like that. If you look at an integral in terms of y, then it's going to be rectangles going this way. Instead of vertically, we're going horizontally. And the integral, the bases, and the heights will be now very different. The base is going to be a horizontal distance. And we want to make it positive. So if vertically you make it positive by going upper minus lower, and horizontally you make it positive by going right minus left. Now that again might be a curve minus the axis, or an axis minus the curve, or a curve minus another curve. So it'll look different in a lot of different cases. The heights are very small changes vertically. Now if I'm changing vertically, then it's not a delta of x, it's a delta of y, and infinitesimally small it becomes dy. Now here's the next change then. If I'm integrating with respect to y, then the limits of integration shouldn't be about the left edge or the right edge of the x region. It should be about the low and the high, or the y region. So when you integrate with respect to x, it's right minus left dy from low to high. That's pretty much what this is, all right? Now let's look at a case or two. So if you had a situation like this and you wanted to make positive area, or find the area enclosed by the curve, and in that case, the right of each of those segments is the curve, and the left is the axis, so 0. So here's your right minus left for the bases, and the height is dy from low to high is from C to D. So say you look at the other curve. The limits of integration are from hello, C to D. The bases, to make the bases positive, I'll go right minus left. What's right of all those segments? 0. And left is the curve. And the height is a small change up and down, which is dy. Okay? If you get two different right minus left situations, where you, instead of going curve minus 0 the whole time, it ends off, then you'll need two integrals. So for this, you might say the lower region is from C to D, and right minus left is f of y minus the axis 0, dy. But then you hand off to a different region from D to K. Right minus left is 0 minus f of y. After that, you can simplify and call the 0, just put a negative out front. That's the process. All right, so let's look at a case, or 2, or 3, or 4. Say I had x equals 4y minus y squared in the y-axis. What does that curve look like, please? Sideways, probably, yes. It factors well, I think you'll agree. Are those x-intercepts or y-intercepts I'm looking at? Y-intercepts at 0 and 4. And does it open right or left? Does it open? Open, that makes sense. Does it open to the right or to the left? And if you're not sure, what can you do to verify? Plug in a point. If y is 2, for example, to get kind of the inside of the parabola, if y is 2, what's x? 4. So that puts me here. That seems to indicate that it's opening that way. Right? Now let's set up an integral that will yield positive areas. The bases of all those rectangles are horizontal distances, so to make those positive, I'm going to go right minus left. The right is the curve, and the left is the axis, and because they're horizontally oriented rectangles, I'm going to use dy as the height. So what's the integrand? If I go right minus left, and that's curve minus the axis. 4y minus y squared minus 7. And the limits of integration, are they vertical from the low to the high, or horizontal parts of the region? Vertical from 0 to 4. All right? What's the antiderivative of 4y? 2y squared. And the antiderivative of y squared, or negative y squared? Negative 1/3 y cubed from 0 to 4. So maybe something like 2 times 16, so 32 minus 64 thirds minus 0 Get a common denominator mentally, calculate that, what do we get? Yeah, that'd be 96 over 3 minus 64 over 3, which is indeed 32 over 3. All right. Now, one of the reasons, besides it goes so much easier if you use y here as opposed to x. If you used x, you'd have to do two integrals, or two different equations for that square root function. It wouldn't be that actually. It would be 5 minus 5 plus. But it's a mess. Some regions you have choice of x or y, but one's easier than the other. Here's what I mean. Okay, if you look at negative or natural log of x plus 5, natural log of x normally has an asymptote at the y-axis and crosses at 1, 0 and goes that way. Yeah. But what does the 5 do in this case? Shifts it right, left, up, or down? Left. It's easiest to imagine the asymptote, first of all, 2, 3, 4, 5. The asymptote is at negative 5, and the x-intercept now, instead of being at 1, is shifted left 5, so negative 4, yeah? If I were to graph that, then it looks like that. They talk about the area between the x and the y-axis and the curve, so that's this kind of quasi-triangular region. Now, this region, I'm not saying in the question use x or y, but imagine if I did leave it up to you and you used x, then the rectangles would look like this, yeah? You might think, okay, it seems no big deal. I don't know why the y stuff. Well, the integral, what would the integral be? The integrand, really. Don't worry about the limits. The limits, I guess, would be negative 4 to 0, which is nice. But what's the integrand? What's the height? Natural log of x plus 5. But we do not know how to integrate natural log of x plus 5 yet. We will, but not yet. Okay? So you kind of stuck. Let's say then we try and get unstuck by looking at it from a different direction and use rectangles going this way. The minute you use rectangles going sideways, you're saying, I'm going to use y as the variable of integration. So the integrand, the bases are horizontal. So right minus left to make them positive. What's right? Yeah, and left is, it's the curve, right? I think we can agree with that, yeah? But because the heights are dy, I need to write the curve in y terms. That's often going to happen. You're going to be given the equation in x terms. When I say x terms, I mean it's written solve for y in terms of x. And you'll want to go the other way and write it solve for x in terms of y. Solve this for x, please. X is e to the y, that quantity minus 5, right? Now, if I take 0 minus that whole equation, then it becomes more like 5 minus e to the y. Now, isn't that a heck of a lot easier to integrate the natural log of x plus 5? Okay. So that's the good. The bad is the limits are not quite as pretty, but that's okay. The limits, remember it's the low and the high. I need to, if it's y, I need to write the low and the high limits. What's the low? That's not bad. 0. What's the high? How'd you do that?
I said, for the x equals e to the y minus 5, I said x equals
Right.
e to the y minus 5 equals 0.
Okay. So if, and you could go either place to find this, but you do indeed have to say add x equals 0, what's going on? And the y is natural log of 5. All right. Now we're rolling. If we integrate, the antiderivative of 5 minus e to the y is 5 5y minus e to the y from 0 to natural log of 5. Anytime I see a 0 and an exponential, I'm careful. I don't say, oh, that's going to be 0. So at natural log of 5, I get 5 natural log of 5 minus e to the natural log of 5. That's nice. At 0, I get 5 times 0 minus e to the 0. So out of those 4 terms, 3 of them stay, 1 drops out. So what are the 3 results that stay fairly cleaned up? 5 natural log of 5 stays. E to the natural log of 5? Be just minus 5. And then at the back end, e to the 0 is something. I get a plus 1. So I've said 5 natural log of 5. Okay. That's kind of hard to verify. I'm getting positive there, but if you got into it, you would see that that is a positive answer. So we are doing it. So far, so good? Okay. Let's talk area between 2 curves rather than the axis. You could think of these are all the area between 2 curves where the axis is a curve, really. But I'm saying 2 non-axis curves. So in the simplest possible case, if you get one region, then you just say what's the right, what's the left, and the bases. To make them positive, you take right minus left. In that picture, then, right is f, left is g, so I'm doing right minus left for the base, and the height of my rectangles is dy. What about in this? In that, we have 2 regions, so we'll need 2 integrals. What's the lower integral? Or the integral for the lower area? C to d of? Kind of hard, you have to trace back. G minus f. Yeah, G is the solid. G minus f dy. And then from D to K of dotted, which is f, I believe. Okay. F minus G. You follow? Okay. So, specific examples. Find the area enclosed by x equals y squared, which is a single equation if we write it in terms of y, but if we were to solve it in terms of x, it would be plus or minus. So all of a sudden we get 3 equations to get 2. That's one reason why y is better to use. Y equals x minus 2 is written in terms of x, so that might be a problem later. We'll deal with that. But I see a situation of one area. What should I do after a good sketch, if possible? Yeah, let's find the intersection points that will become our limits of integration. I'm going to go with in terms of y. So y squared is good. The other equation solved for in terms of x and in terms of y would be y plus 2. Yeah. So if both y's or x's are equal, then y squared equals y plus 2. Y squared minus y minus 2 equals 0. Y minus 2y plus 1 equals 0. So it seems like the y's at the intersection, which is what we want, are negative 1 and positive 2. That seems in keeping with my picture there. Follow? All right. So the integrand, or the integral, the integral is from negative 1 to 2. What are the bases of the rectangles? Using right minus left to make them positive. Y plus 2 minus y squared. Excellent. It's the line minus the parabola in y terms. And that's where he's getting it. The heights are dy. Can I do any combining within the integral before I integrate, or just start integrating? Just start integrating. So the antiderivatives are 1/2 y squared plus 2y minus 1/3 y cubed from negative 1 to 2. At 2, I'd get 4/2 plus 4 minus 8/3. And at negative 1, I'd get 1/2 minus 2 plus 1/3. And 3/2 plus 6 minus 3. 3 plus 1.5 is 4.5. Cool. All right, another big reason to use y is because arc sine is hard to integrate. You have to use integration charts, a technique I learned or Friday, Thursday. Sine is easy to integrate. So if I could put this in terms of y, it might be easier to work with. But that's for in a second. Let's first get a picture. Please tell me, even if it's a lie, that you can graph y equals arc sine of x. You can. All right. Can you just picture it, or do you need to sketch a little sign and then invert the points? Give me some points on y equals arc sine of x. I'll give you the softest one is 0, 0, right? On normal sine, the waves go horizontally, and this next good point is pi over 2, 1. So on the inverse, that point becomes 1 pi over 2. And on this side of the origin, this point that is normally negative pi over 2, negative 1, when inverted becomes negative 1, negative pi over 2. And then the issue is, okay, I know it's not linear through those points, it bends. You have to make sure you bend it right, because if you don't, you'll get the integral set up incorrectly. You'll have the wrong right minus left. So make sure you bend it correctly. Does it go this way? Why not? Because that's sine. If you continued, the way to answer your question is if I continued, would it be going up or horizontally? And that goes horizontally. That's bad. So that's bending the wrong way. It must bend this way, because if I kept going, that would go up. Do you follow? All right, then. Oops. What about, although it looks funky, it's pretty straightforward. What's y equals pi over 2x look like? It's a line with a y-intercept at 0 and a slope of pi over 2 over 1. So that, thankfully, encloses one region or two. Two. Normally when I get two regions, I need two integrals. But do I need two integrals in this case, or is there a way around it? You could use one word. I was looking for symmetry. Aren't these regions symmetric?
Yes.
Because those functions are both odd. Okay?
Yes.
So because they're both odd, by symmetry, it's two regions, but by symmetry, I could get the total area as saying 2 times one of the areas. So let's just do that upper right region. From where to where? From 0 to 1 or from 0 to pi over 2? 0 to pi over 2. The rectangles are going this way. Remember, we're trying to get this in y terms. I don't want to do line minus arc sine and integrate that. I want to use y so I can use sine instead of arc sine. So I'm going right minus left. What's right in y terms? Sine y. What's left in y terms? 2 over pi y. That's the basis, and the height is small dy up and down. Okay? That's not too shabby. What's the antiderivative of sine y? Cosine or negative cosine? Negative cosine y. What's the antiderivative of 2 over pi y? I'm getting a little confused. 2 over pi, I'll leave there. 1 over 2 y squared. I agree. So the 2's drop out, yeah? Okay. Again, don't assume that zeros yield zeros. Sometimes they yield things. So negative cosine pi over 2 minus 1 over pi over 2 all squared minus negative cosine 0 minus 0. Okay, what is cosine of pi over 2? 0. How about that pi stuff? What does it come out to be? Negative pi over 4, I agree. What about the cosine 0 stuff at the back end? Plus 1. All said then, something maybe like 2 minus pi over 2. Always check for positive. Is that positive? Yeah, pi over 2 is about 1.5 or so. At least it's positive. That's a good start. You tracking? Okay. All right. And then finally, again, a big part of the skill now that anytime you have two methods, whether it be, substitution or elimination or anything like that, it helps to know the strengths and weaknesses of one and choose well. Anytime you have multiple strategies, you want to choose the path of least resistance. Now you have rectangles horizontally and vertically. And it helps to know which one would be less work, because I think we can all agree we want to minimize the amount of work we have to do. So say you were looking at the region of the square root graph shifted down 5. And that's not what I wanted. Oh well. Yeah, that's not what I wanted. Would you just do the square root graph? Sorry. Let's just do the square root graph and the line with a y-intercept of 3 and a slope of -1. And the x-axis, obviously that would be very different if they said the x-axis versus the y-axis. The x-axis with those two is this quasi-triangular region here, yeah, with its base along the x-axis. Do you follow? Okay, now then, it says find the area using x then y, the objective to give you a feel for how much more work one is than the other. If I use x, then my rectangles will look like this. Is this going to be pretty or pretty ugly? Oh well, we'll deal with it. We're smart. Sort of. It's not going to be pretty, is it? What would be better there? Square root of... that's okay. We'll deal with it. We'll use our calculator. No, it says use a calculator. I knew that. All right. So, here we go. What do you see as far as an x setup? Let's use our calculator. Get your calculator out. Shooby-doo. Let's start with the biggest question, 1 integral or 2? Yeah, it'll have to be 2. Why is that? Oh, that's true. Let's use 2. Square root of x and negative x plus 3. Okay then. What will I have to do? Or what do you want me to do? Find the intersection point. Shucks. Okay, now this is where things start to get a little different. You're going to want to store both the x and the y. Okay, so store that first. The x, oops, shucks, I did that wrong. Store the x to A and the y, darn it, to B. If I, when you go back to, I think that was there, when you go back to the home screen, would you like to intersection? When you put the intersection, if you just call out x and the intersection and say you stored there, meaning it together, it's incorporated. And if you just account for y, the y will also be stored in the y. Go back to your home screen and restore it. All right, do you have those stored, my friends? Yes? No? Okay. Good deal. Actually, it wouldn't be that hard to find the intersection points by algebra, but we'll save ourselves some time. 1.697. All right. So, if I do this in terms of x, my first integral is from where to where? 1.697, I think it was. Is that correct? Of what upper minus lower? Square root of x minus 0. I wouldn't count off if you didn't put 0, but I think you'll find it helpful later if you just kind of get in that habit. The next integral is from 1.697 to where the line hits the axis, which would surely be 3. And what's the upper minus lower in that situation? Negative x plus 3. And so on. All right? You may slap that in your calculator if you like. And we'll verify. Oops. Certainly we should get the same answer for both approaches. So if we go shift plus 0 to A. The square root of x is so clean, I might as well just type it in rather than recall the functions. Plus shift plus A to 3. Did you get 2.3226? I could do a rectangle around that and enclose it and see if that's a reasonable estimate, but it feels like it's pretty good. All right, now if I were to do the same problem in terms of y, the beauty of y in this case is that as opposed to the x, where it's 2 upper minus lowers, when you do y and the rectangles are going this way, you're doing right minus left. And it's always the same right and always the same left. So you really only have to do one integral if you did y. It is from 0 to, what's the b of my intersection point? What's it? 1.3027. Okay. 1.302. And what's the integral? Right minus left in y terms. So this would be something like x equals negative y plus 3, and this is x equals y squared. So what's right minus left? Negative y plus 3 is the right, and the left is y squared. If you put that into your calculator, now the calculator, the Inspire anyway, can handle y just fine, but if you have an 84, you just use x and in your mind you pretend it's y. 0 to b of negative y plus 3 minus y squared dy. And certainly when you find the same region either way, the answer should come out the same way. Okay, the idea being that one approach is easier than the other, so make it right. Are you tracking? Okay, questions on set 80, 90, 60? 60? 65? 6? 66. Hit me now, I'm ready. 66.
9, 14.
9 and 14.
60.
60.
8.
8.
24.
I think I just erased period 2's questions that I was supposed to put up at lunch. That's all right. I'd probably blow them off anyway, huh, Waller?
Yeah,
See?
you probably would. I'm not even joking. And I'm still mad.
You're real snippy.
Yeah, I am.
Gosh, you should lighten up. Take years off your life, get more sleep than your math teacher.
I mean,
Or at least take points off your grade.
and it shows like you followed your own word and you have a problem.
Wow, you're a real naggy wife.
Yeah,
Yes, you'll be turning it in, come heck or high water. Oh, you're right. You're right. Yeah, you get 2 days. So I guess yours is due Wednesday, yes? But did you get it? You got it that day, right?
yeah.
So how about tomorrow? All right, 9. Question 9, is 9 still a question unto me? It's not changed, is it, right?
No.
It's just the
It's
book.
not a specific question, I just didn't get the answer.
Oh, okay. All right, absolute extreme at an endpoint or a critical number.
That's pretty easy.
The endpoints are x equal -3 and 4. The critical points are where the derivative equals 0, and the derivative is 4x squared minus 4x minus 15. Does that factor 60, 61, 30, 15, and 4, 10, and 6? Yeah, it does factor. Do you agree? Okay. So something like, let me go at it, the old AC method. 4x squared minus 10x plus 6x minus 15. I don't know if that's how you guys learned how to do this, but it works for me. 2x minus 5, 3, 2x minus 5. So it seems like 2x minus 5 times 2x plus 3. Wait. So your roots are x equal 5 halves and -3 halves. And are both of those in the domain? They are. Darn it. 4 candidates then. F at -3 is, I don't have the function up here. So is it that we disagree with their evaluation of the function values? It sounds like we have all the same candidates, is that correct?
Yeah, I had the same candidates, but
Yeah.
when I plugged in the numbers, I didn't get the same.
Okay.
It might have just been, because I did it all without a calculator.
That's
It might have just been the evaluation of
Okay.
candidates.
So 4/3, that is the hardest, the actual most, the biggest source of error. 4/3 of -27 minus, let's see, 2 times +9 plus 45, -36.
Good morning, Dublin Jaguars. Please rise to the pledge of
I
allegiance.
get 9 on that. Do you agree?
Ready?
Got
Begin.
Oh,
I pledge
negatively, yes.
allegiance to
You're
the
right.
flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
-9, I agree, you're right.
Do you toss and turn and can't sleep at night?
At
When these books help you turn out the light, join us at any time after school on December 13th to browse our used book sale.
Hey Dad, consider participating in Cause for a Cause, the Dublin Giving Tree gift drive. There's a tree in the front office. Each of the call or
Oh boy, 256
on the
thirds.
front as well as instructions on the back. Feel free to take your
-32
bring back
minus
your bag with the unwrapped gift before December 15th. This is a great opportunity for Dublin students to take care of families and friends in our community.
256 minus
Your exploration series on
276.
are leading the world into the future. Continues the
It's like
library commons
-20 thirds there. Do you agree with that?
Meet Mr. Robinson, who works at Lockheed Martin. He has 33 years of experience in
256
software
thirds
engineering and
minus
spacecraft,
32.
rocket and missile programming, and is utilized to develop flight
Okay,
simulators
cool.
for stealth fighters and bombers.
It's time for the 24th annual Holiday Brouhaha Improv Show this Friday, December 8th. 2 shows featuring the all-new improv Robert Rama with a straight improv show immediately after school and a competitive improv show at 7. As always, all you need is a $3 donation to attend.
You want to help us out with our pool rental fee? We'd love for you to stop by the Girls Swim and Dive Team Chipotle fundraiser this Wednesday, December 6th, from 4 to 8 p.m. in the Southwest Plaza Food Court. Please mention Devlin.
Here at Tuck Tuck Thai Grill and help the boys basketball team. Mark your calendars for Wednesday, December 13th for Tuck Tuck Thai Grill. All 3 locations, all day. Mention Devlin Rocks at the time of your purchase, and 100% of your purchase will be donated to your Devlin boys basketball team.
100%? Wow, that's really generous.
There will be a parent interest
And I
meeting
like
for a
Tuck
summer Mexico trip in the library tomorrow, December 5th, from 7 to 8 p.m. See Mrs. Stevenson if you're interested but cannot attend.
Dazzling Jazz. The high school flowers of the month for December were selected by the math department and are as follows. Akia Hofmeister was nominated by Mrs.
Oh,
Stewart
that's
for her
something else.
dedication
Did
to passion for
they
math.
factor out a grades point?
Dovetail is always thoroughly certified and is thoughtful in her class participation. Her mastery of content allows her to be a help to others. She has earned 100% on more than one
Maybe they
semester.
did do that.
Great job,
I
Akia.
consider those.
It's possible they did something like crazy like that.
Dedication to learning AP statistics. Jack participates and asks thoughtful questions. He has no problem helping others in class, and students often seek his help.
Oh.
He has earned a 100% on many of the tests this semester. Great job, Jack.
If you got
You're
a
also
comment,
very
maybe
attractive.
this sounds like.
Devlin boys basketball. Boys basketball is on the road to meet on Wednesday, but clear your Friday schedule and come support your Jags as they take on Fort Morgan at 7 p.m. in the jungle. L3 and JV play starting at 4 p.m. Good luck, boys.
Congratulations to girls swimming hoops. Mostly mountains,
Oh, it's replacement?
Tonight at Confer High School, your Dublin girls basketball team will be playing at 7 o'clock, so come out and support them. That's all the announcements. Have a great day.
Yeah, that's.
16?
Yeah, if you're about ready to just looking at it.
Oh, okay. Split it, then you're good. All right,
I'm just not gonna worry about it.
and then 8. Ah,
Oh, I don't need 8 anymore.
Oh, I do.
8.
Reference triangle.
Yeah, it's really funky looking. DYDX equals R2. All right, now first of all, because it's R2, you didn't have to do the whole process. You could just use the derivative, normal. So if that is the case, then you might start there. Say the derivative of our tangent is 1 over 1 plus whatever squared, and in this case it's sine. But then the antiderivative, or the derivative of the inside by chain rule. Something like that. Okay? Yes? 24? Yeah, that was so cool. Do you even know what you found? Darn it. You found a formula for the area of an ellipse. The area inside of an ellipse is that.
But I found it wrong.
Okay, so first of all, when you integrate, what you're doing there was found in a previous lesson as what you're supposed to be doing. This represents 1/4 of an ellipse. Okay, just in terms of what the heck you're doing, which is pretty cool. The B over A is constant, and then the hint they're giving you is that when you isolate that, that's actually corresponds to the area inside a circle. It's 1/4 of circle area. It is the top half because it's positive, but it's only the right quarter because the limit. Yeah. So it's 1/4 of pi r squared, where the r is the a. So that tells you that 1/4 of the region is 1/4 pi a squared, or 1/4 pi a b.
Thank you.
You bet. So hold it. I think that's all they wanted was I think the answer was the 1/4 pi a b, but
Yeah.
to me the real point of it all is the ellipse formula.